Thank you, Lawrence. So Lawrence gave us a very nice introduction to what is machine learning and a glimpse of some of the applications that are possible with machine learning. So at Google, we saw the enormous potential that machine learning was beginning to have all around us, and that led us to releasing TensorFlow as an open source platform back in 2015. And the objective of doing that was to give everyone access to this open source library to develop machine learning solutions. And thereby our aim was to sort of accelerate the progress and pace of the development of machine learning. So since that time, TensorFlow has become enormously successful. In about these 3 years, it has grown to become the #1 repository on GitHub for machine learning. And we are very proud to have been named as the most loved software library or framework in the 2018 Stack Overflow Developer Survey. So all of this success actually in large part is due to the very enormous group of users and developers that we have out there who are using TensorFlow and building a lot of these interesting applications. We are blown away by these download numbers, used more than 17.5 million times. The number that we are very proud of is the more than 1,600 contributors, and vast majority of them being non-Google contributors. And you see very active engagement by the TensorFlow engineering team with the community in answering issues and fielding pull requests and so on. So it's a very thriving an active ecosystem that TensorFlow has generated around it. If we look at where our users come from, they come from all parts of the globe. So these are self-identified locations from our users on GitHub who have starred TensorFlow. And you see that they come from every time zone on the Earth, down in the south, right up to Antarctica, and right up in the Arctic Circle in Norway. And I think I see a dot there in Ireland as well, which might be Lawrence, yeah. So, it's used everywhere for a wide variety of things. So let me switch gears and talk a little bit about the architecture of TensorFlow, what it is, what it lets you do. So I'll talk briefly about the APIs that it has, and then describe sort of the platforms and the languages that it supports, and then take a quick look at some of the tooling that really makes it as a very useful platform for doing machine learning and letting you do sort of a very versatile set of things. So to look at the API for TensorFlow, fundamentally, it's a computation execution engine. And by that, what we mean is that you code your machine learning algorithm or your steps, as Lawrence was showing in that example. And then TensorFlow sort of automates all the mechanics of the training process and on running it on your device of interest and lets you build that model and then use it in practical applications. So you do this by using these higher level APIs as an easy way to get started. And we have two sort of paths of doing this. Some of you might be familiar with Keras as a library for developing machine learning models. And TensorFlow has full, tight integration with Keras. And in fact, Keras is the preferred high-level way of building machine learning models using sort of these Lego bricks, which let you piece together models one layer at a time and build pretty complex architectures. So you can use the Keras library. In addition, we also package some of these very commonly used models by what we call estimators. And these packaged models are sort of battle-tested and hardened, and they let you do your job quickly based on architectures that have already proven to be valuable. And there's also a lot of flexibility in customizing things and changing things and wiring them any way you need to for your application. So these APIs for model building are fed by data. And part of what TensorFlow offers is very flexible libraries for building these data pipelines, for bringing in data into your models and then doing some of the feature transformation or pre-processing to prepare the data so that it's ready to be ingested by a machine learning model. And then once you have all this set up, then we have sort of this distribution layer, which basically deals with abstracting away your model and distributing your training job to run on a CPU or single GPU or multiple GPUs, or even on custom architectures such as TPUs, which we'll talk a little bit more about as we go forward. So having trained your model then, you save your model as an object. And this object basically captures the architecture of the model as well as the weights and the tuning of the knobs that you did during your training phase. And now it's ready for use in your application. And that's where you, again, have a very flexible choice of how to use that trained model. You can use a library such as TF serving to manage the whole process of serving. You can deploy it on mobile devices, or using TensorFlow JS, you can deploy it in the browser. And we'll talk more about all of these later today, as well as there are dedicated talks on each of these components where you can learn more about them. So on the platform side, as I was saying earlier, TensorFlow lets you run your machine learning models on CPUs, GPUs, as well as on these custom hardware such as TPUs, as well as on the mobile devices, be it Android or iOS framework, and then going forward on lots of these embedded or IoT type devices. So talking a little bit more about the platforms, one platform that we are particularly excited about is cloud TPUs. So cloud TPUs were announced by Google actually last year, and then this version 2 of the cloud TPUs was made general availability earlier this year. And these are specially designed pieces of hardware from the ground up, which are really, really optimized for machine learning type of workloads. So they're blazingly fast for that. Some of the specs are there, extremely high performance in terms of compute, as well as a large amount of very high bandwidth memory, which lets you sort of parallelize your training job and take full advantage of this kind of an architecture. And the nice thing is that TensorFlow is the programming environment for cloud TPUs, so TensorFlow is very tightly coupled with being able to do this sort of seamlessly and easily. So let's see what's possible with these types of devices. Here I'm showing you some numbers from training what's called the ResNet 50 model. So ResNet 50 is one of the most commonly used models for image classification. It's a very complex deep learning model which has 50 layers, hence the name ResNet 50. And it has more than 20 million tunable parameters which you have to optimize during the course of training. So this turns out to be a very commonly used benchmark to look at performance of machine learning tools and models to sort of compare how well the system is optimized. So we trained the ResNet 50 model on a public data set called ImageNet, which is a data set of tens of millions of images that are labeled for object recognition type of tasks. And this model could be trained on cloud TPUs for a total cost of less than $40 with an extremely high image throughput rate, which is mentioned there. And that lets you take the entire ImageNet data set and train your model in a matter of tens of minutes, what used to take hours, if not days, a few months or years ago. So really exciting to see the pace of this development to do machine learning at scale. On the other end of the spectrum, we see enormous growth in the capabilities of these small, mini computer devices that we carry around in our pockets. Smartphones, smart connected devices, IoT devices, these are exploding. And I think by some counts, their estimates are that there'll be about 30 billion such devices within the next 5 years. And there are a lot of machine learning applications that are possible on these types of devices. So we have made it a priority to make sure that TensorFlow runs and runs well on these types of devices by releasing a library called TensorFlow Lite. So TensorFlow Lite is a lightweight version of TensorFlow. And this is how sort of the workflow works. You take a TensorFlow model, and you train it offline on, let's say, on a workstation or in sort of distributed computing, and you create your saved model. That saved model then goes through a converter process where we convert it into a model that's specifically optimized for mobile devices. We call it the TensorFlow Lite format, right? So this TensorFlow Lite model can now be installed on a mobile device, where we also have a runtime for TensorFlow, which is a TensorFlow Lite interpreter. So it takes this model and it runs it. It binds to the local hardware acceleration, custom hardware acceleration on that device. For example, on Android, you have the NNAPI interface, the neural network interface, which takes advantage of whatever might be the hardware configuration. And this gives you a model that's lightweight, it uses less memory, less power consumption, and is fast for use on mobile devices. So here's an application of, here's an example of how this might look in practice. What you are seeing here is a image classification example running on a mobile phone. And we are holding common office objects in front of it, and it's classifying them in real time: scissors, pen, Post-its, and obviously TensorFlow logo. It's very sort of easy to build these types of models and get these applications up and running very quickly. And there are examples and tutorials on our YouTube channel to show you how to do this. So in addition to the flexibility on the platform side, TensorFlow also gives you a lot of flexibility in programming languages that you can use to code it in. So we have always had a large collection of languages that have been supported. Python continues to be the mainstay of machine learning, and a lot of work being done in that area. But you can see many more languages, and most of these actually have been developed through community support. Two languages we are particularly excited about, which we launched earlier this year. One is support for Swift. So Swift gives some unique advantages by combining the benefits of a very intuitive, imperative programming style with the benefits of a compiled language, so you get all the performance optimizations that graphs typically bring you, and so you can have best of both worlds. Another language that's extremely exciting is bringing machine learning to JavaScript. So there's a huge JavaScript and web developer community out there, and we believe that by using TensorFlow JS, which is the JavaScript version of TensorFlow, it lets JavaScript developers easily jump into machine learning and develop models in the browser using JavaScript or run it with a Node server backend. So we're beginning to see some really cool applications of this. And I'll show you two examples of that here. So this is a tool which you can try out yourself on that site up there. It's called TensorFlow Playground. And this lets you interact with a machine learning model, with a neural network, very interactively in the browser. So you can define a simple neural network model, you can control how many layers it has, how many nodes it has, and then you can see the effect of changing parameters like learning rates, et cetera, and look at how individual the neurons are behaving and what's happening to your model convergence. And these are the types of interactive visualizations that are really possible when you have a browser as a platform for machine learning. On the TensorFlow JS website, you can see a lot more really fun examples. My favorite one is the one which lets you drive a Pac-Man game by using hand gestures or head gestures. This one is an example of the PoseNet model, where a machine learning model can be fed to webcam data to identify human pose, and then this data can be used to drive or control actions. So again, all the source code for this model and is available, and the model is also available in trained form that you can use. So just finally, I want to talk a little bit about some of the tooling that makes TensorFlow very sort of flexible and easy to use for a variety of applications. One example of such a tool is TensorBoard. So TensorBoard is the visualization suite that comes with TensorFlow. And by using TensorBoard, you can sort of dive into the complexities of your model, and you can look at the architecture of the model. You can see how the graph is laid out. You can break down your data. You can see how the data is flowing through the network, look at some convergence metrics and accuracy and so on. It's a very powerful way of working with your machine learning models. What you're seeing here is a visualization of the MNIST data set, which is the handwritten digit recognition data set. And you can see how your data set clusters and whether you have a good distribution of different types of labels in your data and how they are separated. So we talked a lot about machine learning model development. It turns out that in order to put machine learning into practice and really using it in a production setting, it takes a lot more than just the model itself. So you have to deal with a lot of things related to bringing the data in, and then dealing with model serving, model management, and evaluating the performance of models, and keeping them sort of refreshed over time, and the lifecycle management of models. So for this, we recently open sourced an extension to TensorFlow called TensorFlow Extended, which really deals with this process of end-to-end machine learning and gives you a lot of tools that you can use to deal with these system-level aspects of end-to-end machine learning. And my colleague Clemens has a talk later this afternoon where he dives into more details about what all you can do with this platform. So with this sort of brief introduction to TensorFlow, let me turn it back to Lawrence, who will show how we are making it easier to use and get started.
Thanks, Sandeep. My mic's still working? Here we go. So as Sandeep showed TensorFlow and some of the things that we've been able to do with TensorFlow and what it's all about, one of the themes that we've had for this year in TensorFlow is to try and make it easier for developers. So what I want to share is 4 of the things that we've actually worked on. The first of these is Keras. Sandeep mentioned, if you're familiar with Keras, it was an open source community framework that it made it easy for you to design and train neural nets. Francois, the inventor of Keras, now actually works for us here at Google, and as a result, we've incorporated Keras into TensorFlow, and to be able to use Keras in TensorFlow, it's as easy as, from TF import Keras. The second thing that we've been working on is something called eager execution. And so I came to TensorFlow as a coder, not as an AI scientist or as a data scientist. And the first thing that I found that it was very difficult for me to understand was how a lot of the things that you do in TensorFlow was that you write all your code up front, you load it into a graph, and then you execute it. And it was hard for me as a developer to understand, because I don't know about you, I'm not a very good developer. I need to write 2 or 3 lines of code, step through them, make sure they work, write another 2 or 3 lines of code, step through them, make sure that they work. And one of the things that we've added is what we've called eager execution to make that possible. So instead of loading everything into a graph and then executing on a graph, you can actually do step-by-step execution now with eager in your TensorFlow application. So you can debug your data pipelines, you can debug your training and all that kind of stuff. I love it. It makes it a lot easier. The third one is something that we've released called TensorFlow Hub. And the idea behind TensorFlow Hub is that it's a repository of pre-trained models that you can then just incorporate directly in your app with 1 or 2 lines of code. And not only can you incorporate the entire model, but through transfer learning, you can actually just pull individual layers or individual attributes of a model and use them in your code as well. The idea behind that is really to get you up and running, get you started quickly in common scenarios, such as image classification, text classification, that type of thing. And then the final one is, it's been designed to help researchers and to make it a lot easier for researchers, and it's called Tensor to Tensor. And the idea, again, behind Tensor to Tensor is to give you pre-trained models and pre-trained scenarios that you can use, you can reuse, and you can start adapting really quickly. But let me start looking at a couple of these. So first of all is Keras. Now the idea is Keras, it's a high-level neural network API. It was built in Python. It's designed to make it easy for you, as I've mentioned, to build a neural network. And one of the things that it does is it includes the ability to access various different namespaces. It allows you to access various different, sorry, my slides animation are broken. Access different data sets. So for example, one data set that's built into it is called FashionMNIST. The graph that Sandeep showed earlier on for handwriting recognition is MNIST. A similar one called FashionMNIST allows you to do a classification on items of clothing. And in the next session after this one, I'm actually going to show all the code for that you can build a classifier using Keras and TensorFlow to classify items of clothing in about 12 lines of code. So I'm going to show that a little bit later on if you want to stick around for that. But very, very easy for you to use. As you can see here, this is in Keras. If I wanted to use something like FashionMNIST, I can just incorporate the data set. And if I want to build a neural network, this neural network is actually what will classify the clothing that I mentioned earlier on. So these 3 lines of code, these 3 layers, are what you'll use to define a neural network that can be fed an item of clothing, and it will tell you what it is. So Keras, designed to make all of that simple. Eager execution, very similar thing. The idea is it's an imperative programming environment. It evaluates operations immediately. You don't build graphs, and your operations will return concrete values so you can debug them straight away. And to turn it on in TensorFlow, all you have to do is say tf.enable eager execution. And if you use, for example, an IDE like PyCharm, that then enables you to do step-by-step debugging through the Python that you're using to build your model and test your model. So TensorFlow Hub, the idea is it's a library of model components that we've designed to make it easy for you to integrate these pre-trained models into your application, or even pull individual layers through transfer learning into your application. And it's just a single line of code to integrate them. And here's a sample piece of code here for it, where the idea is that I'm now the first 3 lines there is I'm calling on hub.module to bring in this NASNet model, and then those bottom 3 lines of code is I can just pull things out of that. So for example, features equals module my images is going to give me the set of features in that model, so I can inspect them, I can adapt them, and I can maybe build my own models using them. And other things like the logits and the probabilities I can actually pull out of that just using method calls. So if you've ever done some simple TensorFlow programming, you might have seen, for example, on GitHub, there were models such as ImageNet that you could download and start using. This brings that to the next level. instead of you downloading a model, putting it somewhere, writing code to read that in, the idea is that there's an API for you to pull it out and also to inspect the properties of that model and use them yourself. And then finally, tensor to tensor, the idea is that this is similar in that it's a library of deep learning models and data sets. We've designed that really for deep learning research to make it more accessible. So for example, if the latest adaptive learning rate method, I think is what we're showing here, then the idea is I can actually pull that in using tensor to tensor. And in this case, the code is actually, this is for translation. So I can pull in the latest research on translation. I believe this one was English to German. And I can use that in my own models, or I could build my own models wrapping them. So again, it's really the whole idea is to take existing models and to make building your own machine learned applications using those models a lot simpler. So those are four of the advances that we've been working on in this year. Whole idea, like we said, the theme is to make machine learning easier. First is Keras for building neural networks, make it very simple. The second is eager execution to make life easier for programmers so that you've got imperative execution. The third then is pre-trained finished models and providing a repository for them so that you can just pull them out using a single line of code and not go through all that friction. And then finally, and like more cutting edge stuff, is tensor to tensor, where some of the latest research is available and some of code that's been written by our researchers is available for you to be able to incorporate their models and their work into your own. So with that, the most important thing for us, of course, is community, and to be able to extend TensorFlow through community, as Sandeep shared. And Ed, who's our specialist in community, will share that with you. Thank you.
Thanks, Lawrence. Hey, everybody. My name's Ed Wilder-James, and as Lawrence said, I work on growing open source collaboration around TensorFlow. The most important thing is that we want machine learning to be in as many hands as possible. So firstly, thank you for being here. And that's one reason that we've convened these 2 days in this conference where you can come and learn about TensorFlow, not from people 5 steps removed from the project, but from the actual developers and product managers who are working on all the features. So please stick with us for this track because you'll be getting it absolutely from the source. Talking about source, so TensorFlow does have a massive worldwide community, and we'd love you to be involved in it. There's 2 places you really need to know about. The first of these is tensorflow.org/community. Anything we talk about today, which is a resource or a user group or a mailing list, you can find from there. So if you're a user of TensorFlow and haven't joined up maybe to the Discuss mailing list, or you don't use Stack Overflow to get your answers, or you don't use GitHub issues to file when you've got a really gnarly problem, please head over and get familiar with those resources. One of the other unique things about these resources is who's on the end of the issue, who's on the end of the Stack Overflow question. It's actually a member of the TensorFlow team at Google Brain a lot of the time who's going to answer your question. We really believe that we should be connected directly to users and be learning from use cases and helping out. So we actually have engineers who basically do a rotation, taking turns to answer Stack Overflow questions and address issues. It's really getting right to the heart of the team when you actually file this. And one of the unique characteristics about TensorFlow as an open source project is you are using the exact same code we use inside Google when you're using TensorFlow. There's no 2 versions, it's the same code. So you're reaching the same folks, and your issues kind of have a similar eye on them as any other person inside Google's would. The other thing we really want to do is encourage and grow more contributors. So if you're a developer and want to become involved in contributing to TensorFlow, there's a developers mailing list. Again, you can find up there. And on that mailing list, we do a lot of things like coordinating releases. We also now, starting in the middle of this year, publish requests for comments around new designs. As you'll probably hear later, we're in the middle of figuring out what TensorFlow 2.0 is going to look like. And a big part of that for us is public consultation on designs. So if you're a heavy user or developer, please play a part in that review. You can join that again through that community page. One other great resource, and this is on the other side if you're new, is Colabs. Has anyone here used a Colab at all? Okay, a few people. So this is a really exciting thing that we brought online this year. Basically, you can use compute resource free on us in the Colabs, where TensorFlow is all set up and ready to use. And one of the easiest ways getting into this is if you're on the TensorFlow.org website and you see code examples, you see that get the Open and Colab button, and you hit that, and boom, you're in a Jupyter notebook running TensorFlow, and you can get access for a limited time, obviously, to GPUs that we provide. So it really is an amazing way that you don't have to worry about the resource, you don't have to worry about installing, you just don't even have to worry about writing the code. You can actually take an example and then start tweaking it straight online, and it's one of the best learning tools for playing around with TensorFlow. And some of the best, the other fun attributes of this are you can save your work to your Google Drive account, so it's not lost, and you can also start up a Colab from any GitHub repository. So that's a pretty powerful tool. Okay, a few other things that are good places to hang out. We have a YouTube channel, and if you've enjoyed Lawrence talking, you can just literally have hours of Lawrence talking and talking about TensorFlow. But one of the fun things he does there as well is gets out into the user base and into the developers and interviews people who are using TensorFlow as well. So if you have a useful and interesting application of TensorFlow, come and find us. We'd love to talk to you. We'd love to profile you, because these things aren't just for us to broadcast out. We want to celebrate the community. Likewise, we have a blog, which you can find on Medium or blog.tensorflow.org. And as well as publishing, I think, what is a really great resource for technical articles and important information about TensorFlow there, we're, again, incorporating content from the broader developer community. So if you're interested in guest blogging, again, come talk to us. We'd love to have a lot of content that reflects everybody using the code. And, of course, there's this little thing called Twitter, which is kind of like our main newswire for everything that tickers over, so releases, important articles, and things like that. We'd love you to hook into all those things. We'd love you to talk to us over the course of these 2 days. We also have a presence at the booth over in the expo area, the sponsor pavilion, and we're hanging around, made sure that we've got a good rotation of people to come that you could talk to. So even if we don't know the right answer to your question, we'll probably be able to say, well, so-and-so is over there, come and talk to him. This is your best chance to get face-to-face information from us, basically. So thank you very much for your attention so far. I know Lawrence is going to speak shortly and guide us into the 2 days. Very grateful for you being here. Thank you.